Here we are at number 2. Now, number 2, we've gone all to the next level of things, because you'll notice that our hydrocarbon is no longer just a simple hydrocarbon. Our hydrocarbon now has carbon, hydrogen, and oxygen in it, which raises it to at least the next level up, if not 2 levels up. This is going to be a far more difficult problem. You'll notice that in the previous problem, we didn't even use this 1.5 grams that they gave us. Wasn't even necessary in that one because it was a very simple problem where we only had the 2 things in here. But now that we've got the 3 things in here, we're going to need to know about that. But having said that, we're going to start off the exact same way. We are looking for C, X, H, Y, O, and Z. The first 2/3 of this problem are fairly traditional. So you're going to start, for example, with your 7.48 grams of carbon dioxide that they gave us here in the problem. And you're going to work your way through, and you're going to figure out how much carbon is there. So first steps first, we're going to multiply that by 1 mole per 44 grams of carbon dioxide. And then you're going to multiply that by 1 mole of carbon for every 1 mole of carbon dioxide. And you get out your calculators and you do 748 divided by 44. That's going to get us 0.17 moles of carbon. So I can go right ahead right now and I can put in 0.17 moles of carbon as my value here for X. So this guy right now is going to be 0.17. That's there, like so. And then I can do the exact same thing, except now I'm going to do it for the water. So here is the water, 3.06 grams of water. So fine. So I have 3.06 grams of water at 1 mole of water per 18 grams of water. And then don't forget this step. Don't forget that you need to know 2 moles of hydrogen for every 1 mole of water that was there. So you get out your calculators, and it's 306 divided by 18 times 2. So it's 0.34 moles of hydrogen that's there. So I can come right up here and I can put in 0.34 moles over here. All right. So now here's the problem with the oxygen. You might say to yourself, well, if I just combine the oxygen from my blue water here, right, if I figure out how much oxygen is there, and then I figure out how much oxygen was in the carbon dioxide that was there and add those together, then that should be my oxygen. Except that some of that oxygen is going to be coming from where you want it to, which is here in the compound. But remember that in order to do this whole process, we had to add in a bunch of oxygen from an exterior source here. So honestly, we won't know how much of the oxygen that was created in this problem, how much of the oxygen that was created here and here actually came from our purple spot there in the oxygen, like so. We can't know that simply by the products. So what are we going to do? Well, the nice thing is we actually know 2/3 of our substance, and by logic and mathematics, if we know 2/3 of our compound, then we actually can figure out what the last third is. How are we going to do that? Well, remember that number that we didn't use last time? Well, we're going to use that this time. I got 346 grams of the C, H, and the O. So I'm going to come down here and I'm going to put 3.46 grams of C and H and O. Now what I'm really interested in here is the oxygen. But in order to figure out the oxygen, I would have to subtract out how much carbon and hydrogen is there. Oh, well that's okay, because I know how much carbon and hydrogen are there. I know that I have 0.17 moles of carbon, and I know I have 0.34 moles of hydrogen. Well, if I know the moles, then I know the grams, so I'm just going to take this one more step. So I'm going to go times 12 grams of carbon for every 1 mole of carbon. So I'm going to take 0.17 times 12, and I'm going to get 2.04 grams of carbon. So, consequently, I'm going to put that in, how about this brown color? 2.04 grams of the carbon. Now I'm going to come down here and I'm going to subtractify out minus 2.04 grams of the carbon that I got from my upstairs number that was here. So again, I know that my original sample had 346 grams in it, and I know from how much carbon dioxide that I created that that had to be 2.04 grams of carbon. Let's do the same thing now, except with the hydrogen. Hydrogen weighs 1 gram, so that's 1 gram per 1 mole of hydrogen. So that's easy. That's going to be 0.34 grams of hydrogen. Go ahead and put that in, how about this yellow number here, like so. And then I'm going to come down here and I'm going to subtractify out 0.34 grams of hydrogen as well. So when we're all said and done here, I've got my 346, I've got my 204, and I've got my 0.34, and I'm going to end up with 1.08 grams of oxygen that was there. Now again, I can't use that number as it is, because what I'm really interested in is the number that's going to go up here, like so. Except remember that the numbers that go in the formula here are not grams, they are moles. We are interested in the moles. So I really just need the moles of the oxygen. Well, that's okay, because I have it. Well, I have the grams, but I can get the moles. So that's going to be times 1 mole of oxygen per 16 grams of oxygen. So divide that by 16, and I get 0.0675 moles of oxygen. So that guy there is my final answer as far as moles is concerned. So I'm going to come all the way back up here, and this is going to be 0.0675. So now that I have all the moles of everything, all I do now is divide by the smallest of the numbers. So divide that by 0.0675, divided by 0.0675, divided by 0.0675. And so that then is obviously going to be 1. So 0.17 divided by 0.0675 gets me 2.5. And then that will then be 5. That was there. 0.34 divided by 0.0675. It's going to be 5. Now remember, you don't want to have a fraction. The empirical formula is the lowest whole number ratio. So if you have a half, all you have to do is multiply all of these guys by 2. So consequently, instead of 2.5, 5, and 1, you're going to end up with 5, 10, and 2. That is your empirical formula. The lowest whole number ratio of the atoms that are in the compound. So this is significantly more challenging than problem number 1, but it involves 2/3 of the process of exactly the same way. You take the carbon dioxide that you're given, you turn it into moles, you turn it into moles of the carbon, and you stop there and you take that number and you put it up top. Then you take that and turn it into grams that you're going to need later. You do the same thing with the water. The water you turn into moles and you turn it into hydrogen. You take that number, you put it up top. Then you turn that into grams that you're going to need later. Later is now. You subtractify out your carbon and your hydrogen to get your oxygen, turn that into moles, and then take all of those aspects, put them together, and you'll be able to get the empirical formula.